Okay, let's go for the next experiment. It's gonna be total internal reflection, right? For this case, let's use a piece of glass, right? And try to reproduce this total internal reflection. From the beginning, let's make an introduction. Remember, every time we have light going from one medium to another medium, right? It transparent mediums, right? The path, right, changes, right? We said that light is being refracted. We know that from the previous experiment, right? For example, imagine this is air and this is glass. So we have the incident ray, right, going through this medium. So we have that light is bent, right? It's refracted, right? Now, if we're going from the glass to the air, the same thing happens. In this case, light is refracted in that direction. Okay, look, if this is air and this is glass, we know from this data right here that N1, right, N1 is greater than N2, correct? Okay, now when this unit of refraction is less than this unit of refraction, right, the right refracted is refracted toward the normal, right? Imagine at the beginning, this is the initial path of the incident ray, right? It's coming in this way, but because of this medium, it refracts. But it refracts toward the normal. Again, when the index of refraction is greater than the index of incidence. Now let's go in your picture right here, in the other interface. Right here, the index of incidence, index of refraction of incidence is glass, and index of refraction, right, medium is gonna be air. In that case, what do we have? Well, we have this incident ray now is refracted away from the normal, right? Away from the normal. Okay, to do this, again, we follow the Eisenhower's law, which says that incident index of refraction times sine of theta, right, of the angle incident equals to N2, right, index of refraction of the medium, in this case glass, times sine theta 2, or the refracted angle, right? Correct. This is a picture. We have incident ray, we have the refracted ray, this is the incident angle, the refracted angle. Okay, now let's use these conditions to study the total internal reflection. Imagine that we're going from glass to air. What happens then? Well, according to this picture, right, the right refracts away from the normal. For example, imagine this is ray 1, right? We go to this interface, right? This is the original path that's going to be refracted away from the normal, right? This is the normal for each point. Now let's go to the next point right here. This original path, again, according to this point, because this index of refraction is less than this one, so the ray is refracted away from the normal, correct? Now we are right here, so it's the original path, it's gonna be refracted away from the normal. Later, the next point is right here, right? This original path is gonna be refracted away from the normal. When this refracted ray is parallel to the surface of this medium, glass in this case, right, we call that angle the critical angle. Why? Because after that, right, if we increase the angle, the ray is not refracted. The ray is reflected toward the incident medium, in this case, the glass. Correct? Now, today, let's find this critical angle, theta c, at which, right, the ray is gonna be parallel, the refracted ray is parallel to the surface of the glass. Great. Again, we know the index of refraction for these two medium. We have N2, which is air, which is gonna be about 1, and N1, which is glass, is about 150, 152. Let's say 150. Okay, great. Again, this is the condition. We have this angle, this ray is gonna be refracted at 90 degrees, means parallel to the surface, and 90 degrees with respect to the normal, right? And that is, again, the critical angle, which is gonna be the same as the incident angle, correct? Now, let's apply Eisenhower's law one more time. And according to this, we have the theta incident of theta 1 is equals to the critical angle, right? And theta 2, the refracted angle is gonna be 90 degrees. This is this condition right here, right on this equation, and solve for N1, which is the incident refraction of the glass. It's known right from the theory, the true value, right, that N1 is about 1.50. Okay, let's take that as the true value or theoretical value for today's experiment, correct? And let's find the personnel. Also, of course, we need to mention, right, the critical angle that we found from this experiment, correct? Because this is a lab report, we need a lab report, please. Let's solve for N1 with formulas and values, right? We have the theoretical value right here. Now let's compare these two quantities using the personnel, right? It's right here, correct? And now let's see how we do it in the lab. Okay, let's do it. Okay, for today's experiment, we have this piece of glass, right? It has the shape of a straight line right here, a circular path. This is one of the ways how we can calculate, right, the total internal reflection. Also, we can use half of a circle, right, or we can use a triangle. I found this material at home, correct, and it works very good for today's experiment. Okay, so we have right here the line which represents the normal, and that's the point right here we are supposed to use for all these refractions. Okay, let's do it. Okay, we are right here with the glass. Look, let's follow the laser, right? As you can see, look, it takes the path right here, follow this path, and then it goes toward, right, the surface, right, parallel to the surface, right? That's the idea. One more time, look, always hitting the same point right here, right, the same point. Look, the laser is going toward the parallel to the surface, right? Got it? That's the idea for this experiment. Let's do it. Okay, and after that, as you can see, the ray is reflected right toward the same medium. Okay, let's do it. Let's take some points of reference, right? Let's take, for example, these points of reference right here, right? Look, the point is right here, imagine, okay? The incidence right here. Let's change the angle, okay? Let's take another one. Can you see it? Now the ray is right here. Can you see it? Look, that's the ray right there. Perfect, it's right there. Okay, great. Now let's change another one. Look, it comes. Okay, I'm looking for the ray one more time. It comes, and it goes right parallel. I want you to see it right here. Look, it's gonna be right here parallel. Looks right there, and right there is parallel, right? It disappears. When it disappears, that's the angle, right, we're looking for. One more time, look for the laser. Okay, the laser is coming, right, and disappears. One more time. I want you to see it, right? Where is it? Okay, one more time. Okay, where is the laser? The laser, come on. I saw it before, please. Okay, one more time. Okay, where is, okay, it's coming, okay, right there, it's coming, and oh my god, I didn't see it. Okay, one more time. Okay, it goes right, let me see, right there, it comes, and disappear there, right? Okay, that's the point I'm looking for. Okay, let me mark it right here, correct? And we created all these a point that help us to study the total internal reflection, right? After that point, look, the rays is refracted toward the same medium after that angle, right? Okay, great. Okay, now let's remove the glass to see the point, right, and mark the rays on this piece of paper, correct? Okay, now let's do it. Let's do it. Looks like I'm missing one point right here, right? Oh my God. Let me see. Well, this is the most important one. Okay, this is the most important one. Let me trace it. Let me trace it right here. Correct. We have this angle, which is the critical angle, right? It's coming from this point to this point. Correct. Now, if this one goes parallel to the surface. Yes, parallel to the surface. I can believe it. Right, in this way. Perfect. Perfect. So this is the critical angle, the angle they give us, the critical angle right here. We also found, right, this angle right here, right? This one, correct? This ray. Imagine this is the situation right here, correct? Okay. And this is what's refracted, right? Was refracted like this. Remember, right? Was refracted like that. Okay. So we have that this way is refracted. We have, oops, another point, right? Another point around here. It didn't mark very good right here, but kind of like this. Okay. Okay. So this is for the other ray that we found. Remember, you saw all the show, right? Very nicely, right? Before. Okay, let me put it right here. Okay, perfect. These are the extra ones that help us to visualize what is happening for the last one right there. Correct? Perfect. Now let's again find this angle, right, from here to here, and this is called the critical angle. Correct. Now from your view over there, or maybe you can print out this picture, right, and use a protractor to find that angle. If not, I can give you more information just in case you don't have a protractor, or maybe you can use your cell phone, right? We have some applications, some apps that help us, right, to measure angles. Maybe you can do that too. If not, let me give you information, more information on this figure, this picture. Okay, imagine that we have from here to here gonna be 10 centimeters, right? This is 10. Okay, how many centimeters do we have in the other side? Oh my God. In the other side, we have like around, oops, what is happening right here? I don't see it. One more time. Okay, if this is 10, okay, let me make it perpendicular, right? Okay, I need this to be perpendicular. Okay, let me make it perpendicular. Perfect, perpendicular to this point. Okay, what's perpendicular over here? Right now, right here. Perfect. Now let's do it. Let's see how many centimeters do we have. Right, right there. Right there we have like 11.2. Okay, 11.2 centimeters. Let's do it. Okay, great. So right here, if we have that this is 10 centimeters, right? Right here we found this is 11.2, right, centimeters. Okay, you can use this data also, right, to calculate this angle, the critical angle, right? And once you know the critical angle, please, and the same piece of paper, you can do all the calculation, right? All the data that you have on the board, right? So what do we have on the board? We have that what should be N1, right? What should be N2? The theta, the critical angle, right? And then from Snell's law, right? Snell's law, calculate, right, the experimental one, right? Everything's on the board, right? It's an extra information right here, right? And so on. Please do whatever is in the board that we introduced before, correct? And this is gonna be, again, today's experiment. Hopefully you will get the right information with this, a good conclusion, right? Very nice experiment. You can do at home as long as you have, right, the equipment. Is very easy and very interesting experiment. Okay, see you in the next experiment. Bye.